What's up guys, welcome back to the channel. So today we are diving into something that I think every single person who is building a house, renovating a property, or doing any kind of plumbing project needs to understand before they spend a single coin at the hardware store. We are talking about the difference between PVC pipes and PPR pipes. Now I know some of you might be thinking they are both plastic pipes, what is the big deal? But trust me, by the time we finish this video, you are going to realize that choosing the wrong pipe for the wrong application can cost you a lot of money, a lot of time, and a lot of stress down the line. So sit back, pay attention, and let's get into it properly. Let's start from the very beginning. PVC stands for polyvinyl chloride. It is one of the oldest and most widely used plastic pipe materials in the world. Walk into any hardware store, any construction site, any market, and you will find PVC pipes stacked everywhere. They are usually white or light gray in color, they feel hard and rigid when you hold them, and they are available in a huge range of sizes. The reason PVC became so popular over the years is very straightforward. It is affordable, it is lightweight compared to metal pipes, it does not rust, and it is easy to work with even if you are not a professional plumber. For a long time, PVC was considered the go-to solution for almost every plumbing need, and in many parts of the world it still dominates the market simply because of its low price. Now on the other side, we have PPR, which stands for polypropylene random copolymer. I know that name sounds like something out of a chemistry textbook, but do not let it intimidate you. PPR pipes are a more modern solution that was developed specifically to address the limitations that PVC had, especially when it comes to hot water systems and long-term durability. PPR pipes are usually green or white in color, and when you pick one up, it feels slightly softer and has a little more flexibility compared to PVC. It has a different texture, a different weight, and even the way you work with it is completely different from PVC. PPR technology came into widespread use mostly from the 1990s onward, and since then it has become the preferred choice for residential and commercial plumbing in many countries around the world. One of the first things you need to understand is how each of these pipes is joined together, because the joining method tells you a lot about the strength and reliability of the entire system. With PVC pipes, you use solvent cement, basically a chemical adhesive that you apply to both the pipe and the fitting before pushing them together. The solvent slightly dissolves the surface of both pieces, and as it dries, the two surfaces bond and harden into one connection. When done correctly, this creates a reasonably strong joint. However, the quality of that joint depends a lot on how well it was applied, whether the surfaces were clean and dry, and whether the correct type of solvent was used. If any of those factors are off, the joint can be weak and prone to leaking over time, especially under pressure. PPR pipes use a completely different method called heat fusion or thermal welding. You use a special tool called a pipe welding machine that has two heating elements, one shaped to fit inside the fitting and one shaped to fit around the outside of the pipe. You heat both the pipe end and the fitting at the same time for a specific number of seconds depending on the pipe size, and then you quickly push them together and hold them still for another few seconds while they cool. When the melted surfaces come together, they literally fuse into a single solid piece of material. There is no glue, no adhesive, no chemical, it is just pure thermal bonding. The result is a joint that is actually stronger than the pipe itself, because the material has become one continuous structure with no weak point at the connection. Now let's talk about temperature, because this is honestly where the difference between PVC and PPR becomes most critical and most obvious. PVC pipes are not designed to handle hot water. The material starts to soften and deform when it is exposed to temperatures above roughly 60 degrees Celsius, and in a real hot water plumbing system, the water coming out of a geyser or boiler can easily reach 70 to 80 degrees or higher. If you run that hot water through PVC pipes repeatedly over time, the pipes will gradually warp, the joints will weaken, and eventually you will have leaks and failures that can cause serious water damage to your walls, your floors, and your ceilings. This is a mistake that unfortunately many people make, especially when they are trying to cut costs, and they end up paying far more in repairs than they saved on materials. PPR pipes were specifically engineered to handle high temperatures without any problem. Depending on the grade and wall thickness, PPR can comfortably handle water temperatures up to around 95 degrees Celsius, and even beyond that for short durations. This means you can run your hot water supply, connect it to a solar water heater, a gas boiler, or an electric geyser, and the PPR pipes will handle it without any warping, softening, or degradation. This makes PPR the only sensible choice for any indoor plumbing system where hot and cold water are both present, which is basically every modern house or apartment. When it comes to durability and overall lifespan, the gap between PVC and PPR is very significant. A properly installed PPR plumbing system can last anywhere from 50 years to over 70 years under normal operating conditions. The material does not corrode, it does not develop scale buildup on the inside the way metal pipes do, it does not react chemically with the water passing through it, and it maintains its structural integrity over a very long period of time. This is especially important for indoor water supply lines that are built into walls and floors, because you really do not want to be breaking open your walls every few years to replace failing pipes. PVC, while also resistant to rust and corrosion, has some weaknesses that affect its long-term performance. One of the biggest enemies of PVC is ultraviolet radiation from the sun. When PVC pipes are exposed to direct sunlight over a prolonged period, the material becomes brittle, it loses its flexibility, and it starts to crack. This is why you will often see outdoor PVC pipes that have been painted or wrapped to protect them from UV exposure. Even indoors, PVC pipes that experience repeated cycles of temperature change can develop micro cracks over time, particularly at the joints. The material also tends to become more brittle as it ages, meaning that an impact or pressure surge that would not cause any problem in a newer pipe can crack an older one. Pressure resistance is another area where PPR demonstrates a clear advantage. Because the heat fusion joints in a PPR system create a seamless, uniform structure, the entire pipe network behaves almost like one continuous piece of material. There are no mechanical weaknesses at the connection points. In a PVC system, the joints, no matter how well they are made with solvent cement, remain a slightly different structure from the pipe body, and over time or under sudden pressure changes, those joints can fail. Water hammer, which is the sudden pressure surge that happens when a fast-flowing water supply is abruptly shut off, is one of the most common causes of joint failure in PVC systems. PPR systems handle water hammer much better because the fused joints can absorb and distribute that pressure without cracking. Another factor that many people do not think about but is actually very important is water quality. The inside surface of a PPR pipe is extremely smooth and non-reactive, which means that the water flowing through it stays clean and free of contamination. The polypropylene material does not leach any harmful chemicals into the water, which makes PPR an excellent choice for drinking water supply lines. PVC pipes, particularly older formulations, can sometimes release small amounts of chemical compounds into the water, especially when the water is hot or when the pipes are new. This is one reason why PPR has become the preferred material for potable water systems in hospitals, schools, hotels, and residential buildings where water quality is a priority. Now let's be real about the cost, because at the end of the day, budget matters. PVC pipes and fittings are noticeably cheaper than PPR, sometimes significantly so depending on your location and the pipe sizes you need. If you are working on a large project and you are trying to manage costs carefully, the price difference between PVC and PPR can add up to a meaningful amount of money. For applications where PVC is perfectly appropriate, drainage, sewage, underground irrigation, stormwater management, there is absolutely no reason to spend more money on PPR. PVC will do the job well, it will last a reasonable amount of time, and you will save money that can go toward other parts of your project. But here is the thing that experienced builders and plumbers will tell you: for internal hot and cold water supply lines inside a building, the extra cost of PPR is an investment that pays for itself many times over. When you factor in the longer lifespan, the lower risk of leaks and water damage, the ability to handle hot water without any issues, and the reduced need for maintenance and repairs over the years, PPR is actually the more economical choice in the long run. The cheapest material to buy at the hardware store is not always the cheapest material to use when you look at the total cost over the lifetime of the building. One practical point worth mentioning is that PPR requires a pipe welding machine to install, which is a tool that not every small plumber or DIY builder will have readily available. This is something to consider when you are planning your project. You either need to hire a plumber who already owns this equipment, or you need to rent or purchase the machine yourself. PVC, on the other hand, can be installed by almost anyone with basic knowledge and just a can of solvent cement, which makes it more accessible for small repairs and simple projects. However, for major plumbing installations in a house, the right approach is always to use the right professional with the right tools, and that investment in proper installation will save you from problems later. So to bring everything together, if you are doing drainage, sewage, underground water lines, garden irrigation, or any application where the water is cold and the pipes are not going inside finished walls, PVC is a solid, cost-effective choice that will serve you well. But if you are plumbing the interior of a house, connecting hot water lines, building a system that needs to last for decades without maintenance, or supplying drinking water to your family, PPR is the material you should be using without any compromise. Know your application, buy the right material, and you will build something that holds up properly for years to come. Alright guys, that is everything you need to know about the difference between PVC and PPR pipes. If you found this video useful, please give it a like because it really helps the channel grow, and make sure you subscribe so you catch all the upcoming videos where we keep breaking down construction and engineering topics in a way that actually makes sense. If you have any questions or if there is a specific topic you want me to cover, drop it in the comments below and I will get to it. Thank you for watching, and I will see you in the next one.